This is Mrs. Reed. Today we are starting a new unit and we are going to be talking about the Pythagorean Theorem. So the Pythagorean Theorem came from the mathematician Pythagoras, and he is the one who came up with this theorem. And there are a couple of definitions that you guys need to know before we start talking about his theorem. And one of those words is the hypotenuse. So the hypotenuse, the definition is the longest side of the right triangle opposite of the right angle. So if I were to draw a right triangle, remember, a right triangle means that it has a right angle in it. They're saying that the longest side of the right triangle, which is this line right here, and it's opposite of the right angle, is called the hypotenuse. Okay? Which means the other sides of the right triangle will lead us to our second definition, and we call these the legs. So the legs are the two sides that intersect to determine the right angle. So here's my right angle, and the two lines that intersect at that right angle are what we call the legs. Alright, remember, you guys can pause this video at any time to write down the definitions and also use closed captioning. I'm going to go ahead and move on to the theorem itself. So here is a better picture of a right angle, and notice that here are the legs that intersect that form the right angle, and then the hypotenuse is the longer side that is opposite of the right angle. Now, we label each legs as A and B, and it does not matter which leg is what. So if you would rather say that this leg at the bottom is A and this leg over here is B, that's totally fine, but the hypotenuse is always labeled as C. So we don't want to, in math, we don't like to use words a lot. We would rather use variables to represent the word. So just remember that the legs, we are going to label them as A and B, and then the hypotenuse, we are going to label it as C. So we can determine a missing side. We can find a missing side in a right triangle based on Pythagoras' theorem, which he calls the Pythagorean Theorem. And this formula to find a missing side is what you guys will have to remember, and you guys are going to hear this every day for about a month until you guys memorize it. And this Pythagorean theorem is a squared plus b squared equals c squared. You guys have to memorize this formula, and we are also going to make you guys write this formula down every single time on every single problem. And if you guys really think about it, it's not that much. We're telling you guys to write 3 letters, 3 numbers into operations. So 1 plus sign and 1 equal sign. That's it. So we're not asking you guys to do a lot, but we are asking you guys to write this down every single time. And again, this formula is going to help us find a missing side length on our right triangle. Okay? So let's practice down here at the bottom. So what we are going to do is we are going to determine whether the given side lengths form a right triangle or not. So the Pythagorean theorem of the a squared plus b squared equals c squared only works on right triangles. So we're going to figure out if these 3 measurements are going to form a right triangle based on the Pythagorean theorem. Okay? So remember, our Pythagorean theorem is a squared plus b squared equals c squared. And if I want to figure out if these 3 side lengths are going to be a right triangle, I am first going to plug in my numbers where they belong in the formula. So a equals 2, I'm going to plug in 2 for A. B equals 4, so I'm going to plug in 4 for B. And C equals 5, so I'm going to plug in 5 for C. All right. And now I'm just going to solve it. And if I have my left side equal my right side, then that means that it is going to be a right triangle. So if I were to take 2 squared, remember that's taking 2 times itself 2 times. So 2 squared is 4. 4 squared means we're taking 4 times itself 2 times. So 4 times 4 is 16. And then 5 squared is 5 times 5, which equals 25. So last step is to take your 4 plus 16. So 4 plus 16 is 20. So does 20 equal 25? No, 20 does not equal 25. So these 3 side lengths are not going to form a right triangle, because when we got down to the bottom, 20 did not equal 25. So this means that no, it's not going to form a right triangle. Okay? So let's try this one. So let's try B. We have 9, 40, and 41. So remember, even though that these do not have what A, B, and C equals, remember your hypotenuse is always the longest side. So if we have these side lengths, 41 is the biggest, so we know that 41 is going to be our C, or our hypotenuse. And then the 9 and the 40 are going to be our legs. And remember, the legs, it does not matter which one is A or which one is B, but the hypotenuse always has to be the biggest side length. Okay? So again, our formula for Pythagorean theorem is a squared plus b squared equals c squared. To figure out if these side lengths are going to form a right triangle or not, we need to substitute these numbers into our formula. So since 9 was A, I'm going to substitute 9 in for A. 40 was B, so I'm going to substitute 40 in for B. And 41 was C, so I'm going to substitute in 41 for C. After you substitute all of your numbers in, you can now just solve it. So 9 squared is 9 times 9, which equals 81. 40 squared is 40 times 40, and that equals 1600. And the last one is 41 squared, so 41 times 41 is 1681. So last step is to simplify your left side of the equation. So 81 plus 1600 does give me 1681. So does 1681 equal 1681? Yep, they sure do. So since the left side equals the right side, this means that these 3 numbers do form a right triangle. Okay? So go ahead and pause the video and try out these 2 problems on your own, and then play the video when you're ready for your answer. And remember, you have to show the formula every single time, as well as the substitution, and then your work to follow. So just make sure you guys are following the same steps like I did. Okay? So go ahead and pause the video and then play it when you're ready. Alright, so let's see what you guys got for C. So again, your formula is a squared plus b squared equals c squared. You guys should have plugged in 12 for A. You guys should have substituted in 13 for B, and then 15 for C. Now we can just go ahead and solve this, simplify it. So 12 squared, 12 times 12 is 144. 13 squared, 13 times 13 is 169. And then 15 squared, which is 15 times 15, gives you 225. Alright, and then our last step is to simplify this left side of our equal sign. So if I were to take 144 plus 169, I get 313. So you guys should have saw that 313 does not equal 225. So this means that these 3 side lengths are not going to make a right triangle. Alright. And then the last one, 5, 7, and 12. Again, you guys should have solved that 12 is our hypotenuse, or our C, since that is the biggest side length. And then 5 and 7 are our legs. So I'm just going to label those as A and B. So when you guys substituted it into our formula of a squared plus b squared equals c squared, you guys should have had 5 squared plus 7 squared equals 12 squared. And then solving it, 5 squared is 25, 7 squared is 49, and 12 squared is 144. So when you simplify the left side, 25 plus 49 gives you 74. So does 74 equal 144? Nope, it does not. So this means that these three side lengths will not form a right triangle. All right, so good job if you got those. If you needed extra help, just make sure you ask your teacher or re-watch the video on how to do this. But we are now going to move on to finding missing side lengths, okay? So notice in A and B right here, they give us the legs. So remember, the legs are what make up the right angle. And then we're trying to find the biggest side, or in other words, the hypotenuse. So we are still going to do the same thing. We're still going to use our formula of a squared plus b squared equals c squared, except this time they don't tell us what a, b, and c equals. We just need to make sure that we know what the numbers mean in the triangle, in the picture, and then plug them in to our formula in the correct spots. So if we're trying to find a missing side length, remember a squared plus b squared equals c squared will give us the missing side length. And we just need to plug in 4 and 3 where it belongs in the formula. So, like I said, 4 and 3 make up the legs of my right triangle, since they intersect and form that right angle right there. So I just need to make sure that I plug in 4 and 3 for A and B, since A and B represents my legs. And again, it does not matter. If you want to plug in 3 for A and 4 for B, that's fine. Or you can plug in 4 for A and 3 for B. Okay? So let's go ahead and do that. I'm going to plug in 4 for A, and I'm going to plug in 3 for B. Now notice I do need to simplify the left side of my equal sign before I can do anything else. So 4 squared is 4 times 4, which is 16. 3 squared is 3 times 3, which is 9. And then now I can take 16 plus 9 to give me 25. Now, what are we trying to solve? We are trying to solve for the hypotenuse. We are trying to solve for C. And notice how we have 25 equals C squared. We need to get rid of that squared so that we could have C equals a number. So, what is the opposite of squaring a number? If you guys are saying the square root, that is correct. Because the opposite of squaring a number is taking the square root of it. Because we're trying to figure out what number times itself would give us, in this case, 25. So to get rid of that squared, we got a square root. And remember, whatever you do to one side, you have to do it to the other side. So now the square root and the square cancel out, and we're left with C equals, which is what we wanted. And then the square root of 25, what number times itself gives us 25? It is 5. And that is our answer. All right, so let's try another one. So again, we're trying to find a missing side length. So if we're trying to find a missing side length in a right triangle, we're using the formula a squared plus b squared equals c squared. And yes, you have to write that down every single time. Then you need to plug in the numbers that they give us into our formula, and you just need to make sure that you plug it in into the correct spots in our formula. So the 16 and the 4, notice how 16 and 4 form the intersection of that right triangle, which means that 16 and 4 represent the legs. And again, the legs are represented as A and B. And then C is represented by our hypotenuse, which is what we're trying to find. So if we're trying to find the hypotenuse, we need to plug in 16 and 4 into our formula and then solve it for C. So if I labeled 16 for A, I'm going to plug in or substitute in 16 for A. I labeled 4 as B, so I'm going to substitute in 4 for B. And then we're trying to solve for C. All right, so remember with equations, we always need to simplify before we start moving things around. So 16 squared should give you 256. 4 squared is 4 times 4, which is 16. And then we're still trying to solve for C. Now notice how I can still simplify one more time. So if I were to take 256 plus 16, I get 272 equals C squared. Now, a lot of students want to say that 272 is our answer, which is not correct because we need to get C by itself. So, just like we did over here, the opposite of squaring something is taking the square root of it. So, when I take the square root on both sides, my squareds cancel out in the square root, so I'm now left with just C. And then taking the square root of 272, I know every calculator is different. My calculator actually do have that square root button. Others will have a x squared button, and your square root is going to be right above your x squared button, so you'll have to hit shift first and then x squared, and it should pop up your square root. If you need help with it, just ask your teacher and they can show you where your square root button is at. But I need to take the square root of 272, and if you notice, I do get a decimal, which is fine, and just make sure in the directions, if it tells you where to round it, make sure you round it where it's supposed to. But since these directions don't tell us, I'm just going to round it to the nearest tenth. So to the nearest tenth would be 16.5. All right, and that is my answer. And the main thing to remember, guys, is your hypotenuse is always your biggest side. So if it's always your biggest side, just make sure that whatever answer you get, if you were to plug it back in for C, that it is the biggest side. So notice how 5 was bigger than 4 and 3, and notice how 16.5 was bigger than 16 and 4. Okay? All right, so I'm going to do 2 more with you guys, and then I want you guys to try 2 on your own. So notice how in C and D, notice how we are trying to find a leg now. So let's see how this is going to work out. So remember, your hypotenuse is always the longest side that is directly across from the right angle. So 18 has to be our C, our hypotenuse. And 6 is one of the legs. And let's just say that this is our A, since they already said that this is our B, which is another leg. Okay? So, same thing, to find a missing side length, we are going to use the Pythagorean Theorem, a squared plus b squared equals c squared. Make sure you plug in your numbers into the correct spot in your formula. So remember, we said 18 was the hypotenuse, which is C, and then 6 was one of the legs, which we labeled it as A. So notice how I substituted my numbers correctly into my theorem, into my equation. And then now we're just going to solve it like a basic equation. So notice how I do need to simplify first by squaring numbers. So 6 squared is 36. 18 squared is 324. And then now notice what we have to do here. So we're trying to solve for b, which means that we need to get b by itself and everything else over to the other side. Well, to do that, I need to move this 36 over to the other side. So what's the opposite of adding a 36? Hopefully you guys are saying subtracting, so I do need to subtract 36 on both sides, because now those 36's will cancel, and I'm left with b squared equals, and when I take 324 minus 36, I get 288. Now this is where it's the same as what we just did up above with finding the hypotenuse. If we are trying to get b by itself, the opposite of squaring a number is taking the square root. So when I take the square root on both sides, the square and the square root will cancel because they are opposites, and then I get b equals, and then the square root of 288 gives me 16.97. So I'm just going to leave it as that 16.97. And then I always like you guys to go back and double check to make sure that your answer makes sense. So remember, we were trying to find a leg here. So if we have a leg, it cannot be more than the hypotenuse. So our hypotenuse was 18. Our answer was 16.97, so we know that we probably did it correctly. Okay? All right, so how about you guys go ahead and try the last three? So the last three you were trying to find legs of, and then pause this video, and then when you're ready for the answer, go ahead and play it, and then I will give you your answers. All right, so D, you guys should have had your formula there. So a squared plus b squared equals c squared. 13 was representing your hypotenuse, so the c, and 5 was representing one of the legs, and we'll just call it a here. When you guys substituted it into the formula, you guys should have had 5 squared plus b squared equals 13 squared. Then remember, you guys do need to simplify everything that you can. So 5 squared is 25. We can't do anything with b squared yet. And then 13 squared is 169. And we do need to solve for b, so we need to move all constants over to the other side. So to move 25, you guys should have subtracted it on both sides, to where we get b squared equals 144. And then your last step to get b by itself, the opposite of squaring a number, is taking the square root, and make sure you do it to both sides. So then you guys should have gotten an answer of b equals 12. And I do want to bring something up that I just remembered. So remember, when we take the square root of a number, we actually get a positive 12 and also a negative 12. But why are we only keeping the positive? So just think that through. Why are we only keeping the positive number? So hopefully you guys are thinking, well, we can't have a negative side length, right? So if we can't have a negative side length, that means that we're not going to keep the negative, and we are just going to keep the positive answer. Okay? All right, last two questions. I will go through these fairly quickly. So remember, a squared plus b squared equals c squared. And this time, they want us to find the a. So again, a is one of the side lengths. So we're still doing the same as what we did with the previous two, except now our a is going to be what we're trying to solve. So 17 was your hypotenuse, 15 was one of the legs, and when you guys substituted it into the formula, you guys should have had a squared plus 15 squared equals 17 squared. Then when you guys go to simplify it, 15 squared is 225, and 17 squared is 289. And then to get a by itself, we need to move the constant of 225 over to the other side. So right now it's adding a 225, so the opposite of adding it is to subtract it. So then 289 minus 225, we get 64. And then your very last step to get a by itself, remember the opposite of squaring a number is square rooting it. So then you guys should have gotten an answer of a equals 8. All right, and the last one. So again, a squared plus b squared equals c squared. You guys are going to get tired of us saying that, but you guys are going to keep writing it, and we're going to keep saying it until everyone gets 100% on these. Notice how 12 is our hypotenuse because it's the length across from the right angle, and 4 is representing one of our legs. So when you go to plug it into your formula, you should have had a squared plus 4 squared equals 12 squared. Make sure you simplify it. So 4 squared is 16 and 12 squared is 144. To get a by itself, we need to move 16 to the right side of the equation, the equal sign. So the opposite of adding 16 is to subtract it. So we now get a squared equals 144 minus 16 is 128. And then to get a by itself, you just square root on both sides. So the square root of 128 is 11.313. So let's say I just want to round it to the nearest tenth. So that would be approximately 11.3. And that is the introduction to the Pythagorean Theorem. So if you guys have any questions, please be sure to reach out to your teacher so that we can help you. And please do not forget to write down the formula and the steps, the proper algebraic steps every single time. Thank you.